Okay, so what I'm trying to do is show you the concept of integration. And the problem is this. If I give you this, can you tell me what that is? Okay, if you know the answer, raise your hand. Okay, don't yell things out. Because if you yell, I can't hear, okay? I mean, because there's too many people yelling. Henry. Okay, you raise your hand and I'm thinking about it. Yeah. Nitya. Janice? X squared over 2. Because if you differentiate this, what do you get? 2x over 2. And the 2's cancel to get you back to where you are. See how they are kind of tied? Okay, one's one way, the other one goes the other way. Is everybody okay on that? Okay, got it? Yeah, so the next one's going to be x squared. What do you think the answer to that is? What do you think the answer to that is?
3x cubed over 3.
Can't be 3 over 3 because that'd be 1. It'd be x cubed over 3. Everybody got that? Well, you said 3x cubed over 3, you said. Well, you said 3x cubed over 3. So 3 over 3. Yeah, that's what I heard you say. Yeah, seriously. I know. Rub it in. I'll rub it in when the quiz is done next week. X cubed over 3. Everybody got that down okay? How about this one here? Think. Okay, think before you blurt it out.
Negative cosine x.
Henry, do you know how to raise your hand?
No.
Okay, Henry? Negative cosine x is everybody, it's Henry on that. Because derivative of cosine is negative sign, and the two negatives would cancel to give you plus sign. Is everybody with me on this? Yeah. So you guys get the idea, okay? You're doing opposites, okay? Notation, okay? All right, so for differentiation, Henry, Monica, whoa, man, whoa, is that Leah? What are you doing here? No, just for the day? Just to celebrate my birthday? Where's my gift then? Hello? You can't show me my... Okay, so you guys, I don't mind you sitting there, but chupka. Okay? All right, so we've done differentiation, and some of the other notation we've seen here is y prime, right? Okay. And then there was another one that looked like this, which is not used in this book. So we're going to have notation for integration. Okay, so look at all the components that are there. See this giraffe sign here? I call that a giraffe sign. Okay, that, I mean, because it is, right? It is. So that's called the integration symbol, okay? That's called the integration symbol. Then this red thing that's there, okay, it's called the integrand. And then you will have something that's either a dx, a du, a dt, okay? D something. That'll be your variable of integration. So if you give me a giraffe sign like this, that's complete and utter bullshit. Okay, don't do that. Don't do that. Okay? You have to have, in this case, a dx. And if it was this, then you've got to have a dt. Okay? Because without that, it makes no sense at all. Okay? It's not legal. Okay, and then one more thing that you need to know is this thing here called the constant of integration. Okay, and this is a must as well, and we'll see that again in a minute, okay? See that again in a minute. So, did everybody get the components here? Okay, Karthik, no hugs for you. Right? Isn't that called hugs? Yeah, no hugs for you.
Who calls it hug?
Dakota did. No, it sounds good.
Exactly why it sounds. It makes it.
No, it sounds. Yeah, I think it sounds. I thought it was pretty creative. All right. So here's an example. Okay. So here's an example. Notice that this guy shows up now. Do you know why we need that? Yeah, because if you differentiate this side, what's the derivative of negative cosine alpha? Sine alpha. What's the derivative of C? 0. Derivative of constant is 0. That's why you need this, because if you differentiate this, your answer is this integrand here. Okay? So, for example, your answer could have been minus cosine alpha plus 2. If you differentiate this, you still get the same integrand. If it was minus cosine alpha minus 10, okay, you still get the same thing. So what happens is that your answer is a family of answers, okay? And then later on, we'll try and learn how to figure this out. How do we find that? Okay, there will be cases where we'll learn how to find that. Now, this integration that you have is called an indefinite integral, because you'll see another kind later that will be like this. Where you've got numbers at the top and at the bottom. These are called the limits of integration. Sorry? What was that? Right, it's the same thing. I mean, it's just, yeah, it's not. And when you do this, and so this is called a definite integral, because there are definite limits there. Okay, and when you do a definite one, there is no C. Okay, so make sure you understand these two cases. And that plus C is really important, okay, particularly in your quizzes and tests. If you don't have that, you will get a point taken off. So I'm telling you this up front, okay? It's not trivial. Don't just drop it. All right? So everybody okay on that? Okay. All right. So you guys know that calc rules, right? You guys know calc rules. Yes? So it'll be this. Okay, do that. And it'll be the second half of that sheet, okay, this part here. And the good thing for you guys is you don't have to memorize this stuff. You don't have to memorize this stuff. Okay, so. Sorry?
Do the AP kids have to?
Yes, yes.
Wow.
Yeah. They got to memorize all that stuff. So here's our first example. Okay, so the first example that I want to do is Tatiana here, this way. Okay, I know. I think I'm better looking than you though, dude. Anytime, Henry, anytime. You can be 16 and I can be 16 as well, but... Okay, so it's integral of square root of x. So the first thing you want to do is you want to rewrite it with the power. Okay, you want to rewrite it with the power, like so. Right, you guys know that square root is to the 1/2 power. Kritik, Mukte. Nahin, either nahin, yes. Okay, go into your rules book. Okay, this is NFL time. Go into your rules book. Find me a rule that's going to help you do that. Madison, don't share it with him. He's trying to get fresh with you. Yeah, thank you, Madison. Nice. Good job. Hold it like that. He doesn't have it. He gets to pay for it.
It's okay. I have it all memorized.
Yeah, sure you do. Anybody found it?
Formula 5.
Power rules.
Is there a power rule in the front of the book? No, that's exactly what I want you to do. It's not in here, so you better write it down here. It's not on this. Okay? So you might want to write that down. So the power rule goes like this, okay? Integral of x to the n dx equals x to the n plus 1 over n plus 1 with the condition that n is not equal to negative 1. And you guys can see why it cannot be negative 1, right? Because otherwise the denominator would be 0. Okay? So it cannot do that. Right? So notice that that power rule is not on that formula sheet that you printed out. Okay? So you might want to write it down in there. Okay? So if I want to use it for this problem here, what is n equal to? Half. So what's my answer going to be? Yeah, but don't write it like this, okay? This is pretty sophomoric. Because half plus 1 is 3 over 2. So you get 2/3 x to the 3 halves. Plus.
C.
Yes, you see. Emily, no gaming here right now. You're zoning, man. Okay, if you were to differentiate this, what would you get? Yeah, the 2/3 and the 3 halves would cancel. And this would be x to the half. What's the derivative of c? 0.
0.
So then this becomes x to the half. Okay? Which is what you have here, what you started out with. So that's the good thing about integration, okay? You can always differentiate and see whether you're smoking or not, okay? You can always see whether you're right or not. Guys okay on this? Yeah? So you got the power rule down? Yeah? Okay. Okay, I'll do this one too, okay? So do you mind if I write this as is this okay with you? Right? You can divide the denominator into each one of the top parts. Okay? Just like you can do for this. Okay, just like you can do for that. Right? So same concept. And can someone convert these to powers now? X over the root x. Nice, good job. And 1 over root x. Nice. And if I use the power rules, what do I get? Well, first of all, give me the coefficient. 2/3. We just did this. We just did that. And then the next one. Sorry? 2x to the half plus c. So let me explain where these are coming from. Yeah, let me explain and then you ask me, okay? Remember the power rule tells you that what you want to do is you want to add 1 to the exponent and divide by the result. So a half plus 1 is 3 over 2. If you divide by 3 over 2, it flips over. Got that? Okay. And then you're going to add half to negative a half and divide by the result. So minus half plus 1 is a half. If you divide by half, it becomes a 2. And here's your new exponent. Okay, you guys got the power rule down okay? Eric, you here? You're zoning too. I think people in red tend to zone more. Yeah, seriously. There's a zoner there and there's an ultra zoner there. All right, last example and you guys get to do that. Okay, again, use the power rule. I already gave it to you. Right, it's 2/3 x to the 3 halves plus 2x to the half. Plus c. Okay, Teddy. Rub it in.
Is it not 0? You said before that the other one
What's 0? What's 0?
was 0.
No, no. If you differentiate, it's 0. Okay, so power rule this guy, and then we are done.